What's up, guys? Nitty Gritty Maths here, and today, as you can see, we are doing limits. And what a limit actually is we're not actually at a value. It's like we're approaching a value. And I'll show you right now as I erase this board. It's like we're approaching a value. So, okay, we have a graph here, or a function, y equals x squared. And we'll say the limit, okay, we'll call it f of x instead, since the convention of textbooks and questions are f of x. We'll say the limit as, we'll say x approaches 0, we'll call it a value first, x approaches 0 of f of x. And the way we're going to solve this question, we're going to draw a table and analyze it. So -2, -1, 0, 1, and 2. We're going to plug -2 into the equation. We get 4, 1, 0, 1, 4. So we can see from the table, we're going up from one point, then going down, then we're going to hit our minimum, then go up, and then back up. And what we're analyzing is x at 0. So we're going to draw our graph. I'm going to use my different color here. And we see that at x squared and at 0, especially as we come from the left hand side, it will be 0, and from the right hand side it will be 0. So the answer here will be equal to 0. So we can go from the left hand side, the right hand side, and now there's another rule called the left and right hand rules. And in limits, both limits have to be equal to one another for the limit in general to be true. So what I'm saying here is the limit of x approaches, we'll say a value a of f of x, has to be equal to the limit of f of x as x approaches from the right hand side is equal to the limit as f of x approaches from the left hand side. So I'll draw a graph here, and we'll draw a function. We'll draw this, that, we'll draw that. So right here at a, call that a, right here. From the left hand side, we're coming here, that's this negative part. We're approaching a, and from the right hand side we're approaching a from that side. It looks kind of simple using regular graphs and polynomials, but once we get up to discontinuities and in a later video, then you'll know why we're using left and right hand rules. But another limit question here is using the limit definition. So, or not the limit definition, x approaches 0 but 1 over x squared. How would this change the look of the graph? So if you have a general understanding of the graph, it makes the question much simpler. And we'll say the graph of this looks like that. There's a vertical asymptote. There is a vertical asymptote at y equals 0 and a horizontal asymptote at x equals 0. And what we can confirm here is the answer here is infinity, because as we approach from the left and right hand side, so the limit as x approaches from the left hand side, so from the right hand side, since it's positive, from this side it's going up to infinity, so it's equal to infinity. And the limit as x approaches the negative side from here, it goes to infinity as well. So both left and right hand sides are equal. That's why they both are infinity. Similarly, if we erase everything except for the equation, we see we'll change that to x cubed. How does that change the equation? And as we see, our graph will look different, just a little bit. We will still have a part of the graph here, but over here we will have a part of the graph here. And what we notice from the limit as x approaches from the positive side, it's going towards infinity. But the limit, as x approaches from the negative side, is going towards negative infinity. So since they are not the same, the limit does not exist. And that for that question, the limit does not exist. And a rule here, there's 3 rules you need to know, which really help save a lot of time. If you guys want to see a proof of this, leave it down in the comments. I'll probably make a video about this proof. But the limit as x approaches infinity, not a value this time. All these are rules as x approaches infinity. We'll write all of them. We'll say x over a, x over b, x over a, x over b, x over a, and x over b. If a is greater than b, so the exponent here is greater here, then your limit is equal to infinity. And if they are equal, then it's the ratio between the coefficients of these guys. So we'll call the coefficients here f and g. F and g. These are the coefficients of these terms. So the answer here would be f over g, the coefficients of the exponents. So the whole term. And if a is less than b, then it's just 0. And fundamentally, you know, these are all correct, since if a is really big, since we're going to plug in a really big number to find the limit as x approaches infinity, the x here will get really, if a is greater than b, then it'll get really large, greater than a, and greater than the bottom part, which will give us a really big number. And likewise, if they're both the same, and we divide, so if we have an equation here, we'll say x squared plus 5 over x squared plus 4. There's only a slight discrepancy here, so that's why the limit here as x approaches infinity is only 1. So that's going to be your horizontal asymptote, and we'll talk about that as we do horizontal asymptotes and vertical asymptotes in a later video. And here, if the bottom is really big, so if you have a really big, so we'll say very large number over something, we'll just say a constant, a very large number, you're just going to get 0, because 1 over a million is going to be really small. So that's very close to 0. Imagine having a really big number at the bottom. You would have a very small number close to 0. But that's the end of this video for limits. I hope you enjoyed. Hope you learned something about limits. Leave a suggestion down below for future videos. Stay tuned for my next video for review for Calculus 1. But as always, Nitty out.